You ever notice how some of the most beautiful things in the world, whether it's a tiny fern leaf or a massive cathedral, seem to share some kind of hidden design, a secret that connects them all? Well, today we're going to pull back the curtain on that secret in this look at the architectures of recursive harmony. Okay, so let's just dive right in with a bit of a mystery. What in the world could a fern, a Bach fugue, and a mathematical fractal possibly have in common? I mean, they seem like they're from completely different universes, right? But the answer is actually so elegant, and it's been hiding in plain sight this whole time. First up, just think about nature. If you look really close at a fern, you'll see that each little leaf is basically a perfect miniature copy of the entire branch. Or how about a snowflake? Each of its 6 arms is an identical, intricate crystal pattern. It's a world of patterns within patterns. Okay, now let's switch gears to music. If you've ever really listened to a fugue, you know that it starts with just one single melody. Then that same theme gets echoed and woven over itself again and again. It's like a conversation where one idea just keeps getting explored, building this incredibly rich sound from just one simple starting point. And finally, architecture. Picture yourself standing in a giant Gothic cathedral. You look up and see the huge main arch. But then you notice that the windows have smaller, similar arches, and the carvings have even tinier ones. It's this beautiful cascade of repeating shapes that all work together to make the whole building feel like it's soaring. So, what is the common thread here? It really feels like there's some kind of universal blueprint at work, doesn't it? Like an instruction manual for creating complex, beautiful things? And it turns out there is, and it's built from just 2 key ingredients. So let's get into ingredient number 1. Which is really the engine behind this whole thing, recursion. Now I know that might sound like a jargony computer science term, but the actual idea is incredibly simple and really, really powerful. All recursion is the process of repeating a simple rule on its own results. The best way to picture it is to think of those Russian nesting dolls. Each doll has a smaller, identical version of itself inside. Or, that crazy infinite tunnel effect you get when you point a video camera at its own screen? That right there is recursion in action. You can really break it down into 3 easy steps. 1, you start with one simple instruction. 2, you do it. And 3, this is the magic part, you apply that exact same instruction to the thing you just made. And you can just keep doing that over and over and over. But, just repeating a process isn't enough. That could just create chaos. It needs a goal, a beautiful outcome. And that brings us to our second key ingredient, harmony. Now, when we say harmony, we're not just talking about music. We're talking about a much bigger idea. It's that pleasing, almost satisfying quality we feel when different parts just fit together, when there's an underlying order. It's that feeling of rightness you get from a really great design. And this really makes the relationship crystal clear. Recursion is the how. It's the process. It's the engine chugging away doing all the work. Harmony is the what. It's the beautiful, amazing result. It's the magnificent machine that little engine builds. So the really crucial thing to get is how these 2 powerful ideas, the simple process and the pleasing outcome, combine to create what we can call the harmony engine. This is where the magic really starts to happen. Because this right here, this is the core formula. You take a simple rule, you apply it again and again, that's the repetition, and the result you get isn't a mess. It's this stunningly complex harmony. It's like the universe's ultimate trick for building something intricate out of something simple. So now let's put it all together. Let's go back to our original examples, the fern, the fugue, and the cathedral, and actually see the hidden code of this harmony engine at work in every single one. Check this out. For the fern, the simple rule is just grow and create a tiny copy of yourself at the end of each frond. The result? A beautiful, self-similar fractal pattern. For the fugue, the rule is state a melody, then repeat it a little differently. The result? A rich, complex tapestry of sound. And for the cathedral, the rule is take an arch and put smaller, similar arches inside it. And the result is this awe-inspiring structure that feels incredibly detailed but perfectly unified. The mathematician who pretty much invented fractal geometry, Benoit Mandelbrot, he summed this up perfectly. He realized that nature doesn't use simple shapes like spheres and cones. He said it shows an altogether different level of complexity. He was talking about that beautiful, rugged, infinite detail that can only be built through recursion. And it all comes back to this. 1, just one simple rule. One elegant idea, repeated again and again, is somehow enough to create so much of the beauty we see all around us. It's really an incredible testament to the power of simplicity. So, all of this leaves us with one last, pretty fascinating question to think about. If this simple, elegant code is the blueprint for ferns, for music, for mountains, even for galaxies, what can we build with it next? As creators, as artists, as innovators, what's the next amazing thing we can design? The possibilities? Well, they're literally infinite.